Hello and welcome to Chapter 1, Section 7. So we talked about relations last time. This time we're talking about functions. So a function is similar to a relation. We're going to see some examples as we talk through it. But we can determine whether a relation, when you have different points, x and y coordinates, we can determine is that a function. And we can also find some function values. So some of the vocabulary we'll talk about, different kinds of functions. This vertical line test is very important. We'll talk about the meaning there and how that helps us to determine whether something is a function. It's very important. We'll learn about function notation and nonlinear functions. So this information you should have already written, but in case you didn't, we can talk about it briefly. A function is a relation where each element of the domain, each x value, is paired with exactly one element of the range, each y value. In other words, if you did a mapping of your points, x's and y's, you would see an arrow going to one point and one point only for each x value to each y value. And when you graph that, you would see something like this. That would represent a function. You can imagine having a vertical line and drawing it across the shape. If that vertical line, as you drag it across the shape, never touches 2 points at once, then it passes the vertical line test. So imagine a vertical line going across this whole graph here. It would never touch 2 points at once, so this is in fact a function. So first example, we want to determine whether this thing is a function. Now, if we think about the fact that a function must have an x value being paired to one and only one y value, well, this passes that. Everything's 1 to 1 here. So that works. So our answer, we should see that this is in fact a function because the mapping shows every element of the domain is paired with exactly one member of the range. So for this example, it is in fact a function. Okay? None of these points in here are repeating. So this is a true function. This is 1a. 1b, we want to determine whether this one is a function. So this one, they give us the information in the form of a table. And we can think about these points and think about if anything repeats, if it is in fact a function. So is every x value paired with one and only one y value? Well, 7 goes with 12, that's fine. -4 goes with -9, that's fine. 2 goes with 3, and 5 goes with 0. Okay, so none of those repeated. So that looks like a function to me. So your table that you can copy down shows you that answer 1b is in fact a function. So yes, this represents a function. You don't have to write all these words. You just have to say yes, it is a function. We understand that it's a function because each x value, each part of the domain, is paired with exactly one y value, exactly one element of the range. Remember now that we said range is our y value and domain is our x values. So in other words, these are x's, these are y's. Every x value must be paired with one and only one y value, and that's what we see here. 2a, looking at this table, we've got 3 different pairs. We want to say, what is the domain and what is the range of this function? So just to practice our vocabulary skills here, domain tells us we're talking about x values. Range tells us we're talking about y values. So if I was going to list the domain, I know that it's all the x values, which for this one, the periods are x's, the number of students are y's, those come second. So our periods are 1, 2, and 3. That is our set for the domain. And our set for the range then will be all the y's. So for this example, the number of students for each one of these is our range. So you want to write that in brackets. 352, 304, and 391. And we'll close that bracket. So there's our domain and there's our range for this function. Just separate them out, x's and y's. Whenever you have two variables, one's x, one's y, the x's should come first, the y's should come second. So just like we said there's your domain, and there's your range for this example. So hopefully we're getting that vocabulary at this point. 2b asks us to state whether this function is discrete or continuous. So we've got two things there to talk about. Discrete and continuous. So think about what the word continuous means. Continuous means it's always going, that it's all connected, that it never ends, there are no pauses in the flow of whatever it is that we're talking about. So for math and functions, a continuous function is seamless. It's all connected. All the points should be connected by a line. So think about continuous meaning connected. And think about discrete being the opposite of that. Discrete meaning disconnected. I'll circle the dis part of discrete. Disconnected. Okay, so it's not a smooth function. There's parts missing. There's points that aren't connected. That would be discrete. Continuous, everything's connected. So in this example, they ask us which one is it? Is it continuous or discrete? And we know in this example, because the points are not connected, the function must be discrete. It is disconnected. Right? These points are not connected by a line. So that makes sense on that one. 3a, we need to determine whether the line x equals -2 is a function. So graphing something that's x equals some number is a vertical line. So if we wanted to graph that, it would look just like this. We go over to -2 for x, -1, -2, and we draw a vertical line. This line represents every point that has a -2 for x. So down here we'd have -2, 4. This would be -2, 3, -2, -2, -2, -1, -2, 0, and on and on and on. So this is the graph for x equals -2. We want to know, is this a function? In other words, when I'm looking at the graph here, does this pass the vertical line test? If I take a vertical line and drag it across this graph, when it touches, is there ever a point where it touches our line at more than one point at the same time? Well, of course it would. If you put a vertical line right on this line, it touches at an infinite number of points, at many, many, many points. So would this pass the vertical line test? Absolutely not. It would touch at many, many points. So to answer the question, is it a function? The answer is no, because it does not pass the vertical line test. So this cannot be a function. So to answer the question, is it a function? We know the answer must be no. Looking at our next example, we want to determine whether this line is a function. So we have a graphical representation of it here, so we don't have to worry about that part. And looking at the graph, we need to just think about, if we take a vertical line and drag it across this graph, does it ever intersect this line in 2 points at once? Well, I know C is wrong for this example. There's no, we can definitely tell one way or another whether this will be a function. If I take that vertical line across, I don't see any point where it would ever hit more than once. So to me, this absolutely has to be a function. So let's double check that. And we see that, of course, yes, this is a function. It passes the vertical line test. This here tells us a few different ways that we can represent a function. We talked about a table and mapping before. There's also an equation that you can use. That's another way to represent a function, written as f of x. We can also use a graph to help represent a function. So these are just different ways of organizing the same information as we've seen in some examples. So whenever you have a function and you want to write it in function notation, we replace y with f of x. So normally we might say something like y equals 3x minus 4. But now we want to talk about functions, so we want to write it in function notation. So instead of a y, we replace it with an f of x, f next to an x in parentheses, and write the same expression. Now the reason we do that is because it allows us to then say we want to plug in a value, say 4 for x, and it lets us find the value of the function when x is 4. We just say we replace x with 4. So here we can see what we plugged in. And then on the right side, we actually do plug it in and we see what we get out of it. So if we replace x with 4, the value of the function when x is 4 is equal to, and then we just plug it in, 3 times 4 minus 4. So now you just have to simplify a simple two-step equation. 3 times 4 is 12, and 12 minus 4 we know is 8. So the value of the function when x is 4 is 8. And that's our solution to that example. Also, this represents the point in ordered pair where we said x was 4. That's our input. And we plugged in 4 where our output was an 8. That's our y value. So x is always input. Y is always output. We put in a 4 for x. We got out an 8 for y. This is also an ordered pair. So this is another way to write this same information that we found for that example. So on to 4b. Find the value of the function when x is a negative 5 for this function here. So just like last one, we want to plug in a negative 5 for x. And now we solve what's on the right side. 3 times 5 is 15. Keep the negative. Subtract 4 from that. And 15 minus 4 is a negative 19. So the value of our function when x is negative 5 is a negative 19. And there we have that. And again, this is also another point. We could write this as the point. We said x is negative 5. That's our input. And when we put in a negative 5, our output was a negative 19. So that represents a point, negative 5, negative 19. Good. So here we are at example 5. This is the hardest part of this section. Given this whole function here, it says find the value of the function h when our variable t is 3. So don't be thrown off that they changed the letters here. It can be an x, it can be a t, it doesn't matter what these letters are. So the reason these h and t is because we're finding the height of some object at any t time. T is time, h is the height. The letters don't matter, you don't have to know that. You just need to plug in the variable the right way. So wherever there's a t, we're going to replace it with a 3 and then solve the right side of this equation. So the value of our function h when t is 3 equals, and then we replace everything with a 3. So 160 times 3, 16 times 3 squared. And now we just need to simplify this on the right. 160 times 3 is 16 times 3, which is 48, and you add a 0. Here we have 3 squared, which is 9, and 9 times 16 is 144. Now in a calculator in your head, you can simplify this. you would get 912. So the value of our function h at time 3 is 912. And they don't give us the units for that, so it's okay, but we're just working on the mathematical calculations for this example. So there we have it. The value of a function when t is 3 is 912. This is the point 3, 912. So if you understand that, you should be okay in this section as we move forward to our assignment for the day.